when you're doing this, obviously, when you're trying to find all your zeros, you're basically setting yourself up the same way every time. Set aside equal to 0 and find a GCF. Well, are you guys all okay by me just saying the -2 will come out? I get x to the 6th plus 16 as I get to there. All right, Matt? Okay. Now, here's where things get a little. Oh, I forgot to make that an 8. My bad. Sorry. I moved it in my head and I took out that and I just pressed right 8. Now it looks a little bit more palatable looking. So in this case, or in this rate, bless you, what I would start looking at is, notice that it's 2 terms, binomial, and there's an addition symbol. When you see 2 terms with an addition symbol, you need to start thinking, I might have to do sum or difference of cubes. And this being addition, I have to start looking to see if it's going to be a sum of cubes. I have to see, is this possible to be able to rewrite this as a cubed plus b cubed? Well, 8, that's not bad. That's 2 cubed. All right. The other one's weird. How can I rewrite x to the 6th so that it has an external exponent of 3? No, because if you did that power to power, it would be negative 18. See what I'm saying? What do you say? Yes. Exactly. X squared cubed. You're on the right track about the thing about power to power. Okay? So when you see something that's got a weird exponent, take that exponent and divide it by 3. Because you want to do power to power. Because when you have exponents raised to exponents, when you have exponents raised to exponents, you're always going to multiply them together. So in this case, you have power to power, you multiply. Now it fits the pattern. Now it'll fit the pattern of, does that -2 have any bearing upon the problem anymore? No, it's a scalar, it doesn't matter. It's okay, it's gone. So this is where you're going to get your a plus b, a squared minus ab plus b squared as you go through. Fill in the blanks. X squared plus 2. X squared then becomes x to the 4th. Good. And then we have minus 2x squared plus 4. And then this would equal 0. Now, if you check the answers via textbook or Slater or anything like that, these were the problems that said find all the real solutions. There are no real solutions here. You guys know how to find 2 of the imaginary solutions. That's what the x squared plus 2. You guys should all be able to go, okay, those solutions will be plus or minus I root 2. Okay. The other one, not worrying about. Remember we talked about that yesterday? If we get quadratics that are 4th degree, we don't know how to solve those down yet. I'm not going to worry about it. Okay? I'm not going to worry about that. And that's what we're looking for. So here, all you guys would have been able to do was factor it and then left it to zeros. Okay? So when we get to the quiz then on Tuesday with this, maybe a problem like this, I would just say factor. I wouldn't say find 0, so that we didn't have to worry about those imaginary ones for both parts. Okay? Whereas some of the other ones, where we could have, a term of x squared plus 2, x squared minus 4, you can do all those terms without a big hassle. Okay? Were there any? Yes. Find zeros. You can't. It's okay. When you have a quadratic that's the 4th degree, you have 3 terms in the 4th degree, you can't do anything yet. We'll worry about that later. But then you can't use it for 4th degree. So we're not worried about that. If it was squared, yes. Yes, sir. You can't. Remember when I was saying anytime you use sum or a difference in cubes, that trinomial that's left over, whatever the degree is, it's not going to be factorable. If it's a squared term, I think, Melo, we came across those yesterday. If it's a squared term, if it was just x squared minus 2x plus 4, then you could have used the quadratic formula to get the zeros. But it being a 4th degree one, can't go that route. Okay, we're not going to worry about that. Does that seem fair? What else we got? Any others you want to look at here before we talk about long division? Same idea. This one you've got 8x cubed. So it's a cube. It's a difference in cubes. Because what's the cube root of 1? 1. So you wind up with, this is the same thing as saying 2x quantity cube minus 1 cube. So you're going to get 2x minus 1, 4x squared plus 2x plus 1. Generate zeros at 1/2. And then on the other one, you'd use quadratic formula. And I don't know if we did a good full-on quadratic formula one in class yesterday, so let's just do that one real quick. Opposite of b plus or minus the square root b squared minus 4 times a times c all over 2a. What's 4 times 4? 16. What's 4 minus 16? Negative 12. Good. So our discriminant is negative. What's the square root of negative 12? We've done this one most of the time. 2i, yeah. It's going to be 2i root 3. Okay. So we wind up now with negative 2 plus or minus 2i root 3 all over 8. Each one of those values has something in common. Yes. For the zeros. Yeah. Whenever you have sum or difference of cubes, that trinomial is not going to be factorable, so you have to use quadratic. And it's only going to go when you have a square, when it's a quadratic. It's a quadratic trinomial. So now here, everything here is divisible by 2, so your final answers would have been 1/2, comma, negative 1 plus or minus I root 3 all over 4. That's two different solutions because of the plus minus. Write yourself out, not figuratively. Either way. This is why I barely teach math. And then the other one that as a fan. I'm like, do you see a bucket attached to it or a garden hose? Better yet, do you know what a dehumidifier does? Okay. A dehumidifier is basically an air conditioner without the air conditioner coil. It pulls humidity out. Anyway. The more you know. See, I'm not just a savant when it comes to like math things. I know stuff about other things. He's a renaissance. Are we go that far? Make sure your name's trying to send it up. I want to do a quick thing about this crazy stuff called long division. That's fine. Word. Yeah. I guess I said put the 2 days together. Hurry up. We only got about 12 minutes. We got to get through this. Long division. So what I want to just kind of throw up there real quick was something to scary. And go ahead. Yeah. I get the Murphyism out of that one thing. Anyway, so nice, we're good. So when you're doing long division, you're basically trying to figure out how many times something goes into the next inside of it. Okay. The reason why I wanted to show this real quick is that I'm not going to do the whole thing. That's just, but I just wanted to remind you what the process was. So when you did long division, you'd say, hey, does 7 go into 2? And you would say, no. Does 7 go into 29? Yes. How many times? 4. 4. So when you put the 4 above the 29, that meant you're putting it directly above the one that you know that it works with. And what do you do with the 4 and the 7? Very good. You multiply to the 7, and then what do you do? Subtract that, and then what? Bring down the 8. Now what are you doing? Okay. 7 goes into 18. How many times? Twice. Okay. So I put a 2 up here. 2 times 7 is 4. Subtract again. Bring down the 7. Okay. And it's now 6, 42, 54, 7, 49, and 53, which is again 7. Story of my life. That's what? And then lastly, 7 times 7 is what? Now, when we got to this part here, you guys know that you would drop a 0 and go decimals. At some point in time, you did. Just bear with me for a second. Now, this 4 is also represented as a reminder. Remainder. Thank you. A reminder that it's a remainder. So it would be, I don't know if you ever did it like this. 4/7. You write it as a fraction. As opposed to that's it all means the same depending upon what's being asked. Now, obviously this is a messy, horrible looking style process, but we can still do it with polynomials.
Yes.
Now, one thing that I want you to do before you write anything down is know that textbooks always write things horizontally, and I want us to use the long division. They still write it the same way. So what I want you to do is put what's out in front of the symbol first, and then look at the degree of the polynomial you're trying to divide into. What's the degree of it?
3.
3. So how many terms should it have? 4. Is it missing a term?
Yes.
So it needs a what? 0. It needs a 0. It needs a placeholder. So you have to put a placeholder in. Okay? Now this is actually easier than long division with numbers. Nope. So here's what you're going to want to do. What is the leading term of what we're trying to divide into? X to the third. What am I dividing it by? X minus 2. So when you're doing this stuff, you're trying to eliminate the first term every time. So you have to think, what do you multiply x by to turn it into an x cubed? X squared. So whatever exponent I have to multiply by to start with, that's where I place it above the symbol. Now think about what you did earlier. We had 7 on the outside. We divided it. I think the first time went 4 times. What do we do with that 4? We multiply into the 7 to subtract. So what you do here is you multiply this guy to the terms here. You distribute back in. What's x squared times x? What's x squared times -2? And then you subtract. What's x cubed minus x cubed? 0. It's gone. We eliminated that first part. What's 0 minus -2? 0 minus a negative? To bring down the -7. And then I do it again. What do I multiply x by to turn it into a 2x squared? 2x, very good. And notice how that's going to be placed over the x value in our setup. I distribute again. What's 2x times x? 2x squared, good. What's 2x times negative 2? 2x times negative 2? It's okay. You were looking at that. And then again, we subtract out. So here's the reason why we spent that day earlier this week talking about multiplying and adding and subtracting and exponent rules. So you can do stuff like this. So what's 2 minus 2? 0. So our 2x squared, that term is gone. What's negative 7x minus a negative 4x? Excellent. Bring down the negative 6. Again, what do you multiply x by to turn it into negative 3x? Negative 3. Okay. Distribute again. What's negative 3 times x? What's negative 3 times negative 2? 6, positive 6. And then I subtract again. Negative 3x minus negative 3x is 0. Negative 6 minus 6 is negative 12. So that's now a remainder. There's a minus sign here. I remember hearing the noise, but it might not have shown up. That's a remainder. So as a reminder of what to do with your remainder, is that remainder positive or negative? Negative. So what we do is minus 12, what did you divide by? And that's long division. The reason why we talk about our long division is that eventually that remainder becomes for other functions next chapter. Good time. All right, try another one. Try another one. It takes a minute. It takes a minute. It's okay. This isn't long division. This is polynomial stuff. It has nothing to do with. It looks like it. The only thing that's the same is that you're multiplying and distributing. That's the only thing that's the same, and the subtraction. Other than that, it's not heavy lifting. Trust me. I know you can do this. Okay. So when we start this one, write it as 2x plus 3 into cube term. I have 4 pieces. I don't need a placeholder. 2x cubed, 7x minus 7x squared minus 17x minus 3. All right. Very good. You're ahead of me now. What do you multiply 2x by to turn it into 2x cubed? X squared. So I have to place that then above the x squared. That's really the only rule of how to start. You have to place it above whatever degree that you're multiplying by first. You place that above whatever's underneath the divisor. That's really the only rule you have to worry about. Now you just distribute it properly. What's x squared times 2x? 2x cubed. Okay. What's x squared times 3? 3x squared. And now I subtract both parts. 2x cubed minus 2x cubed is 0. 7x squared minus 3x squared is 4x. 10x squared.
What? Are you kidding me? Why does this keep happening to me?
It's okay.
I'm done.
You know what I want you to do? Are you forgetting to put the second subtraction sign?
No,
Oh, okay. To do this, split it. Maybe that'll force you to just stop for like half a second and remember it. It's usually people, if you forget to put that second subtraction sign, that's what you'll do. But if you did did that, maybe remember how we did that earlier this week? We put that slice into it to separate them all?
Yeah.
Try that a couple times, maybe it'll help you out. Oh, I got it. Good conversation, Bella. That was supposed to be funny, Bella. You did laugh. Ooh, I see that slide. There we go. Don't laugh now. Don't do it. Don't do it. All right. What do you multiply 2x by to turn it into a negative 10x squared? Negative 5x. Good. Distribute. We got negative 10x squared. Negative 15x. Subtract. Negative 17 minus negative 15 is?
Oh, 2x.
Negative 2x.
Oh, wait, I had to practice the.
Did you write down 7 said 17? Yep. Before we run out of time, what do you multiply it by now? We got a 0, don't we?
Yeah.
No remaining. Now here's the thing. I posted on the calendar already. I think I have 6 of these for you guys in 6.5. And I also made a quick little review thingy. I know Belle's going to ring here in a second. Just grab one on your way out. Answers on the back, review stuff. We'll go back over long division and start hitting some of this stuff as well. Come Monday. We will quiz through on Tuesday. Nothing better than trying to do that quickly. It was your birthday yesterday? We didn't do anything?
What?
It was your birthday yesterday? We didn't sing? We didn't make a hat?
No?
I want you to do the 6 long divisions and start on that if you got time, since quiz is on Tuesday.